Today I'm gonna show this coil here, but before I start I wanna say I was going to do testing with the alloy 50 cores, but I had a little bit of accident with those. As you can see, I have now a 24 pole rotor here. This 36 pole rotor is a little bit damaged because when I was testing the coils with the alloy 50 core, because of the very strong attraction between the magnets and the core slid through the bobbin core and rammed into one of my magnets. So I had to stop that test. So I am fixing now my rotor, and hopefully it will be as good as it was before. So now I am still doing testing with cores, but this time I'm using ferrite cores. Not gonna use any IL50 cores, only ferrite cores. It does have some pretty good effect. I'm gonna show you with this core. It is a core I wound also. It is performing, yeah, I say good. And of course, now that I have a core, I have more cogging effect, and also there's more drag on the system when the system is open. Gonna start it up now. I'm using this meter here because I can use this meter here now, but I'm gonna drive it at 31 volts, and everything above 30 volts will damage this meter. So I'm turning that one off and using this one over here. It is now at 28.9. When this system is up to speed, I will tune it over here to get 31 volt, which will get me around, yeah, I think it was around 2600 RPM over here. Anyway, let's get it started. As always by hand. Speed number 1. I'm doing only the DC test over here. I'm gonna do a 0.6 watt load with this one, a 1.2 watt load, a 5 watt load. Then I'm gonna short the DC side. Let me go for the second speed over here. Then I'm also gonna fill up this capacitor, and of course measure the RPM after each of these tests. Write them all down and we will see what it is doing. I'm also gonna test this little light here. I don't have any holder for it, so it's gonna be a little bit tricky. Gonna do that at the end. This light here gave me the best output, so I will see. Going for third overdrive speed. So from now on I will be doing only tests with the air core, and if I use a core, ferrite core. If you wanna go for iron cores, just use any kind of iron. You can also use iron and chrome cores, far cheaper. The system has not changed, everything is still the same. Drive side is still the same. It is now at 30 volts. Gonna tune it a little bit for 31 volts. Yeah, that's about right. But let me check the RPM. The system is now open, the coil is open, it's not loaded yet. I think I can do it over here also. $24.72 and climbing. Let's give it some more time. Yeah, 31 volts almost. Just a little bit more. Yeah, it doesn't have to be exactly 31. Something in that range. Let me check the RPM here. It's 2500. Let me do it over here. It's easy for you guys to read, I think. 25, 60, 61, 62. Still climbing a little bit, but I'm gonna start soon. Let me check it one more time. 25, 72. Okay, we're gonna start it. 2572. Start it up. What is it doing? 2600. So the RPM is climbing now on the load. The output is now 12.2 at 130 milliamps. 12.1. 12.1 at 130 milliamps. Let me check the RPM again. 2647. Okay. 2647. Now I'm gonna go for a 1.2 watt load. 2 light bulbs. I'm gonna put this one aside for now. Over there. The output is now 3.4 at 140 milliamps. 3.4 at 140 milliamps. Checking the RPM. 27, 35, 36, and still climbing a little bit. Let's say 27, 41. It is still climbing, but it doesn't matter. 27, 41. Now I'm gonna go for the 5 watt load. Disconnect it here. Don't want to blow out my meter over here. Connect it back here. The 5 watt load is yeah, very lit. It is 2.5 volts at 150 milliamps. 2.5 at 150. Let's see what the RPM is doing. $2,760. 2,760. Now I'm gonna short the coil. It is shorted. Shorted milliamps is 160, but milliamps without volts, it's nothing. You need both of them. You need amps and volt to be able to do something. The RPM is now 2,790. Climbing a little bit, but yeah, let's say 2,790. Now I'm going to fill this capacitor, unplug it here. This one goes over there, this one goes over here, connected it back here. The capacitor is on. In this test, the capacitor and this light bulb here will give me the maximum load on the system. Shorten the coil doesn't give me the maximum load because it makes the system speed up at the maximum. But filling this capacitor and this light bulb does give me the maximum load. And the RPM when I started was oh, let me think of here, was what was the RPM now again? Oh, I forgot. Yeah, I will check it in a moment. Totally forgot about that one. But let's check the RPM at this moment. 2660 and decreasing. So let's give it some time. The voltage in the capacitor now, you can see it over here, 17 point something and climbing at 120 milliamps. We are not going to worry on the drive side, but it is at 31 amps, sorry, 31 volts at 1.2 amps. Let's see what the RPM is doing now. 26, 13, 36, 11, 26, 10, still decreasing. Let's give it some more time. The voltage in the capacitor is now 17.8 at, yeah, let's say 120 milliamps, and the RPM is 26, 5, yeah, 26, 4. It is slowly decreasing a little bit, not much more. It's at 2604, but I'm gonna write here 2600 to be on the safe side. Now I'm gonna open up the coil, remove the capacitor over here, so we can see what the RPM is when the coil is open, because I forgot to write that down, which is not, of course, very important. RPM is decreasing, 2597, 96. Let's give it just a little bit more. What I'm gonna do next is this over here. It's gonna be tricky because I don't have a holder for it. I'm gonna put it over here. Then I'm gonna put the camera down to connect this wire over here. Then I'm gonna pick up the camera and let you guys see the voltage and the milliamps. I cannot read the RPM because I only have two hands, but I know the RPM will be at the same range as the one test with the capacitor, because I done the test already. Let's see the RPM now. The RPM is now 2599. Okay, so open RPM is 2599. So filling the capacitor at 2600 is, you can say, exactly the same. Then we're going to do that light over here. Here is the light. It is very, very bright. Voltage is 17.4 at 130 milliamps, so that's roughly around 2 watts. It's very bright. Like I said, wait a minute, maybe I can read the RPM. Have to put the camera down. Gonna read it now. The RPM is now 2609. Okay. I've measured it. Gonna unplug this. Yes. Memory. It's saying 2609. Can you see that? Hope you guys can see that. Yeah, 2609. So this light over here, 2609, and the output was 17.2, something like that, at 130 milliamps. So that output, 70.2 at 130, is 2.2 watt. 17.2 times, yeah, the wattage output over here is 2.2 watt, which is pretty good. Now I'm gonna remove the coil completely. The coil in place is with the coil in place. Yes. Coil in place, RPM is 2599. No coil in place. Now that's kind of crappy. No coil in place. Anyway, now I'm going to remove the coil, and you will see the RPM is much higher. I have removed the coil, and since the little problem I had with the alloy 50 core popping out, I will be always taping my core when I'm doing tests. Don't want that to happen anymore. The rotor is already at 2988 and increasing 3000 RPM already. So as you can see, with the core in place, not loaded, the RPM is 2599, or you can say 2600. So with the core, even though it's a Faraday core, it puts a lot of drag on the system. RPM is on 3060 and still climbing. Let's give it some time. It's gonna be like 3100 and something, I think. So that's a difference of almost 500 RPM, which is a lot. Now if only I can get the same result with this kind of output with the air core. I do have an air core, which was this one. It also makes the rotor speed up, but the output is crappy. I really don't like that. So what I'm gonna do is make coils with Faraday core and my own winding configuration and see how that works. RPM is now 3097, 96, okay. 3000, let's say 99. That's a difference exactly of 500 RPM. Okay. Yeah, I am thinking about building a generator with this core now. I have to think about it. So see how it goes. Let me shut the system off. Just to show you everything. When I'm done repairing my 36 pole rotor, I will do some tests with it and the same coil again and see how that goes. I really don't like when I damage my rotor. Takes a lot of time to repair them or to make a new one. Anyway, hope you enjoyed it. Thanks for watching.